Good morning to all. Today we are going to discuss about the virtualization topic. The virtualization is a in cloud computing we're just going to discuss, right? So virtualization is the fundamental of technology that power the cloud computing. Actually, it allows you to create multiple simulated environments, virtual machines. In short form, they will call as a VM from a single physical machine. I mean, physical hardware system. And before virtualization, actually, the physical servers or cloud only ran on one operating system. But now, in the cases, it will work on, I mean, we can often one task will be used to run before virtualization. This is wasted the maximum amount of resources. And if your applications only used a 10% of CPU, the other 90% was idle, right? So, uh, the virtualization solved this by allowing one physical server to host dozens of virtual servers, each running its own OS and app isolated from the others. So the core architecture of, the order of the virtualization is a piece of software called the hypervisor. And virtualization is an actual technique which allows you to share the single physical instance of an application or resource among the multiple organization or tenant. Actually, the virtualization is a proved technology that makes it possible to run in multiple operating system application on the same server at the same time. So we are just going to create a virtual system and storage devices and network services. And the technology that works behind the virtualization is known as the virtual machine monitor. Actually, the virtual manager which actually separate the compute environment from the actual physical infrastructure. Before virtualization, the single voice image per machine, software and hardware are tightly coupled. Running multiple applications on same machine often it creates a conflict. So here is the inflexible and costly infrastructure also. After the virtualization, the hardware is independent of operating system and application. The virtual machines can be provisioned to the any system. So it can be managed very easily. Of course, in the operating system and application as a single unit by encapsulating them into the virtual machine. So the core architecture of the virtualization is a uh, hypervisor. Actually, the hypervisor is an out of the virtualization. Actually, they will mean as a piece of software. The physical hardware, the actual server is a CPU, RAM, disk will be there. And hypervisor, it is in a lightweight software layer. Actually, it sits between the hardware and virtual machine. Most of them it will be allocated in the resources like a RAM. Even with the help of a VM1, 2 GB of RAM also we can do it, and we can manage the VM with the help of hypervisor. Actually, with the virtual machine we call as a guest. Actually, it's a software-based computer that can run like a physical one, but it adds its own operating system and application and libraries. Actually, the concept behind the virtualization is we are just going to create a virtual machine over the existing operating system and hardware. Here they will call as a host machine. Host machine means the machine on which the virtual machine is created that we call as a host machine. Guest machine means the virtual machine is referred as a guest machine. So as I said, as a hypervisor is an lightweight software layer that sits between the hardware and virtual machine. It's actually the low-level program that acts as a machine manager. So this is what an architecture of virtualization. And this is a two types of hypervisors are here we needed. One is an hosted hypervisor, and another one is a bare metal hypervisor. Actually, the bare metal hypervisor, we have the can create a number of virtual machines, and how it works means we are installed directly on the physical hardware. There is no host operating system will be there, and bare metal hypervisor, and its performance once we compare with the any other hypervisor, this bare metal hypervisor is high direct access to the hardware resources. So and the use cases of this particular bare metal hypervisor is We can enterprise the data centers and cloud providers like Amazon Web Services and VMware, EXS and Microsoft Hyper-V. So everything is a use case of this particular bare metal hypervisor. And now the second type of hypervisor is a type 2, which is a hosted hypervisor. Actually, it works installed an application on top of the existing OS, like Windows and OS. Windows OS or Mac OS. Performance, once you compare with the bare metal hypervisor, it is a lower. A request must be passed through the host OS first, actually, in this cases. I hosted hypervisor. In terms of hosted hypervisor, you have the use cases like we can use for the personal use. We can also testing in the lab like a Oracle VirtualBox or VMware workstation. We have the types of virtualizations are there. Actually, we have the hardware virtualization, operating system virtualization, server virtualization, and storage virtualization. But actually, not only this four, we also have the application virtualization and network virtualization is also there. The application virtualizations, actually the concept of this application virtualization is we can able to encapsulate the application so it's run independently of the underlying the OS. The use cases, the user access the app remotely without installing it. Example, you can use the Microsoft app, and to run on the Microsoft Excel, you can use an iPad. This app run on the server, but user sees it's on the tablet. And about the network virtualization, it is a decoupling the network for function like routing, switching, and firewalls from the physical cables and switches also. It created a software-defined networks. Example, Amazon Web Service for virtual private network. Virtual private cloud. You can create a subnet and route tables in your software without touching in the physical router. And we also have the desktop application. It's actually the concept of desktop application is hosting a user desktop environment on a centralized server. The user connect via the thin client. For example, the basic PC. For the desktop virtualization, the best example is an Amazon Workshop workspace. The employee log into the from a Chromebook and but sees a full power Windows 11 desktop running in cloud. And hardware virtualizations is a virtual machine manager is directly installed on the hardware system. Is known as a hardware virtualization. The usage is hardware virtualization is mainly done for the server platform. Now, operating system virtualization is a very important concept in the virtualization. Actually, the virtual machine manager is installed on the host operating system instead of directly on the hardware system. That's what we call as an operating system virtualization. The usage of this operating system virtualization is mainly used for the testing the application on different platform of OS. So, and then we have the server virtualization. The server virtualization is actually a concept of prioritizing the one physical, partitioning the one physical server into the multiple virtual server. Example, we can able to run on web server like Linux and database like in Windows and mail servers on Linux, all on one physical machine using VMware XPL. So each virtual machine here is an isolated server that runs on their own operating system like Windows and Linux. Uh, so the VMware is actually is directly installed in the server system is known as a server virtualization. Um, Here actually you can in what we can say the server virtualization is. Suppose we have the web server on one virtual machine. A company that might run on the one web server on one virtual machine and database server on another virtual machine. The file server can be in the third virtual machine and all on the same physical machine only. Uh, Actually, if you do like this, the server virtualization will reduce the cost and reduce the cost, and make it easier to manage and backup the servers. And all, it also allows the quick recovery if even the one VM fails. Also, it doesn't matter of cases. So, like that, we have the storage virtualization also. Storage virtualization actually is a process of grouping the physical storage from the multiple network storage devices. Uh, Actually, it will look like a single storage devices. That's the main concept of the storage virtualization. It is mainly done for the recovery purpose and backup. And what are the advantages of virtualization means? Uh, as per the different virtualization we have discussed and types of virtualization, and it most probably of moving on to the virtualization is the cost. We are just reducing the cost, and maximum hardware utilization can be done in this case. And you can able to test for the software development too, and it will mostly it will increase the availability. It also save the energy and shifting all your local infrastructure to the cloud in a day. That is possible via the virtualization. Possibility to divide the services. And the main disadvantage of the virtualization is the software licensing. Okay, uh, and we have the on-demand provision of computational resources also. It requires the high availability of resources and optimum use. The virtualization is enabling the technology and create the virtual machine that allows the single machine to act as an if they were an mini machine. The benefit of the virtualization is reduce the capital expenses and maintain the cost through the server consolidation, and also reduces the physical spaces needed in the data center. The resource management and migration maintainability and high availability and fault tolerance are the main benefit of this particular virtualization. Actually, the virtualization is implemented through using the hypervisor only. Actually, this is an virtualization. How its virtualization looks. We have that application libraries and operating systems in hardware. Actually, once we creation of the virtual version of the hardware using software, it ran on the server application at the same time on a single physical server by hosting each of them inside their own virtual machine. What I mean is, by running the multiple virtual machine simultaneously, the physical server can efficiently it can be utilized. The primary approach to the virtualization is platform virtualization, that is server, resource virtualization, that is storage networks. What is hypervisor? Yeah, actually, the hypervisor is a very important concept in this case. Once we compare with the cloud computing and virtualization, the virtualization that is a technology that create the virtualization of software. Here we'll use the tools of virtualization is actually is a software technology. Usually we'll own and manage the hardware unless using the cloud. And hypervisor is actually plays an important role in the virtualization scenario by virtualization of hardware. It provides the support for running the multiple operating system concurrently in the virtual server created with the physical servers. The virtualization layer is in a software responsible for hosting and managing all the VM. The virtualization layer is an hypervisor which is running on the hardware. Say for example, VMware. The server without virtualization. Only one OS can run at a time within the server underutilization of resources. It is very inflexible and costly infrastructure. Hardware changes require manual and have access to the physical server too. The server with virtualization can run on multiple OS simultaneously. Each OS can have a different hardware configuration. We can efficiently we can utilize the hardware resources. Each virtual machine is independent. It is isolated from another machines. I mean, another virtual machine. It saves the electricity and the initial cost to buy server and spaces. It is easy to manage and monitor the virtual machine centrally. The hypervisor types are full virtualization. The full virtualization enables the hypervisor to run on the unmodified guest operating system. Example Windows 2003 or XP. And guest OS is not aware that it is being virtualized. Say for example, in VMware uses the combination of direct execution and binary translation technique in order to achieve the full virtualization of the server system. Another hypervisor type is para-virtualization. Actually, it involves explicitly modifying the guest operating system. Say, for example, Linux Enterprise Server 11. It aware of the being virtualized to allow near native performance, and also it can improve the performance, and we can also reduce the override of the to the window. And examples then support the both hardware-assisted virtualization and para-virtualization. The hypervisor implementation approaches are already we discussed about the parameter approach. Diagrammatically, I mean it. It is an actually type one is an hypervisor, and this is an hosted approach. Type two hypervisor, which is a runs on virtual machine on top of host OS. It relies on the host OS for physical resource management. And most operating systems provide the drivers for communicating with the server hardware. Example, VirtualBox. The architecture of the VMware EXIs, right? It is actually the bare metal approach. It's full virtualization is achieved in this case. It is a proven technology. It is used for secure and robust virtualization solution for virtual data center and cloud infrastructure. It will take more advantage of support for hardware system virtualization in terms of 64-bit OS on Intel processor. We also have the Citrix N server. It is actually the open source parameter, often both hardware assisted virtualization and para virtualization. Here we need the virtualization support for the CPU or for the hardware assisted virtualization machine. Zen's loads on initially OS which runs on the privileged case called domain zero. Actually, domain zero is OS is typically the Linux or Unix variant. You can talk directly to the system hardware, whereas other guests and cannot do like that, and also talk directly to the hypervisor itself and allocate and map the hardware resources for other guest domain also. And another type of virtual machine is Ubuntu and KVM. It is a kernel-based virtual machine. It is actually open source. It is a kernel level extension is to the Linux. It is also the full virtualization technique. It supports full virtualization, hence it doesn't need any hardware assisted virtualization support in the CPU. Uh, and which is this is what an actually virtualization concept. And even we have the data virtualization also. Actually, this data virtualization is actually it is an abstract layer that will allow you to access data from the multiple different sources like databases, files, and cloud as if it is for a single P places without moving the data. Say for example, Oracle Data Service is actually the dashboard query, the sales data, and the virtualization layer pulls it from the both on old SQL database and new cloud data lake instantly. So I'll summarize all whatever from the beginning. So what is actually we discuss about what is virtualization, how the world works, and what are the virtual machines or cloud instances are there, and what are the types of hypervisors, and uh, and types of virtualization. We will specifically discuss about the application and network and desktop, storage and servers and data virtualization, and depth of what is actually the server virtualization, and we have a para and full virtualization. And full virtualization, what are the examples of the so this is one of the loss of full virtualization, which is Ubuntu KVM. Thank you. Yes. So full virtualization was a para virtualization. Also, I will discuss about the hardware assisted virtualization technique. Actually, the virtualization technology has revolutionized that way we use the computer resources, allowing us to efficiently utilize the hardware and run on the multiple operating system on a single physical machine. Two prominent approaches to the virtualization are full virtualization and para virtualization, each with its own set of advantages and limitation. In this comprehensive articles, we will develop deep into the difference between the full virtualization and para virtualization, and we can explore the concept, and we can also implement and use cases. By then, you can also have the clear understanding of the when to order of the for one over the other. So the full virtualization is actually this is what in the middle of middle of column. I mean, middle column is the full virtualization. This actually is a virtualization technique that simulate the entire physical computer, including its hardware component, to create a multiple virtual machine that run independently on a single physical host. In this approach, the guest operating system is unaware that it's running in a virtualized environment. As it interacts with the virtualized hardware that emulate the real hardware, the full virtualization works. Hypervisor layer, the full virtualization relies on the hypervisor, also known as the virtual machine monitor, which sits between the uh, physical hardware, physical hardware, and to the virtual machine. And hardware virtualization means it's a full virtualization, but uses the hardware assisted virtualization technique. So actually, it is an Intel VT, and you can also use the AMD V. The purpose is to enhance the performance, and this technology actually to allow the hypervisor to run on the guest OS, and it is directly on the physical CPU without significant performance over it. So that is the main concern of the hardware assisted virtualization. And what is meant by isolation? Actually, isolation was created through the full virtualization, completely isolated from the each other. That is the cases of isolation. And each VM, I mean virtual machine, runs in its own instance of the guest operating system, which cannot be interfere with the other VM. Example, the popular hypervisors for a full virtualization include VMware vSphere, Microsoft Edge, Hyper-V, Oracle VirtualBox, and what about the para virtualization means is actually it takes a slightly different approach to the virtualization. It involves modifying the guest operating system to be aware of the virtualized environment. And unlike the full virtualization, it will also have the guest OS, but it runs unmodified. Para virtualization is actually requires the guest OS to use a specific set of API to interact with the virtualization layer. So what I in the diagram I explained about what is a full virtualization. This is what an actual description of the full virtualization. And data is completely abstracted from the underlying hardware by the virtualization layer. In this technique, the guest OS is unaware that it's a guest, and hypervisor translate all the OS calls on the fly. The main advantage of full virtualization is emulation layer isolate the VM from the host OS and from each other. They also control the individual VM access to the system resource, preventing an unstable VM from impacting the system performance. And it also provide the total virtual machine portability by emulating the consistent set of hardware, I mean system hardware. It also have the ability to transparently move between the host with the dissimilar hardware without any problem. The product like VMware and Microsoft and kernel virtual machines are example for the full virtualization. And what about the para virtualization? How it works and everything, and discussing the diagram itself. But and it actually it's slightly different from the approaches to the virtualization. How it is slightly different means it involves modifying the guest OS to be aware of the virtualization environment. As I said, but in the cases of full virtualization, the guest OS runs unmodified. But para virtualization requires the guest OS to use a specific set of a application programming interface. The purpose to interact with the virtualization layer. How the para virtualization works means uh, this case it is similar to the full virtualization only, but it employs the hypervisor here. I mean, but here the guest operating system are aware of it. The hypervisor provides a set of API and that the guest OS must
used to communicate with the underlying order only, right? The guest OS modification is must be modified to replace a certain hardware related instruction with the help of hypercalls, and which are the calls to the hypervisor. This hypercalls allow the guest OS to request the service from the hypervisor, and such as we can also, memory management or CPU scheduling can be done. The performance benefit of this particular para-virtualization is it avoid the overhead of emulating the complete hardware. It often offer the better performance than the full virtualization, and guest OS can communicate more directly with the hypervisor, resulting in improved efficiency. An example of this one is Zen. Zen is completely, it is a widely used hypervisor that support the para virtualization. It is known for the performance and scalability in virtualized environment. So once you compare with the para and full virtualization required, it's not required and hence unmodified in terms of guest OS modification. But in the cases of para virtualization, it requires the modification to the use hypercalls. Performance-wise, the full virtualization is slightly lower due to the emulation, but in the case of para virtualization, it is a better performance due to the direct interaction. And in terms of isolation, the full virtualization is a strong isolation between the virtual machine, but in cases of para virtualization, is an isolation with awareness of other VM. And guest OS or the flexibility, if you compare with a full virtualization, it supports various OS type, but in cases of para virtualization, it works best with the compatible TOS. And in terms of hardware compatibility, the full virtualization compatible with the most hardware. In para virtualization, actually, it requires the hardware support for para virtualization. In terms of hypervisor layer, the full virtualization manage the virtual hardware independently, but in cases of para virtualization, it provides the API for communication, right? So this is what an difference and benefits and plus and minus of the para and full virtualization.